Well, hello. Today we'll be discussing gears. Hopefully you're not too far behind on the simple machines and everything seems to be pretty crystal clear. And if that's the case, gears will seem just as easy. Gears are mechanisms that are used to transfer energy through rotary motion. They transfer this energy by either changing the speed of the rotation, change the direction of the rotation, or they change the amount of torque available to do work. Gear train. A gear train is when you have two or more gears meshed. Down here is a good example of a gear train. They've got two gears down here that are meshed together. It's a mechanism that's used for transmitting, as we've already said, rotary motion or torque through interlocking teeth. There is a certain amount of torque that's being transferred from one set to the other set of teeth. And then a driver gear is the gear that causes motion. What I want to explain to you here is, let's say this is the one that's being driven by an axle, by some type of motor. This one is spinning and it's causing this one to spin. So this one right here would be the driving gear, the gray one. Gears. Mating gears always turn in opposite directions. So as we said here on this one, if this gear was being driven this way, clockwise, then this one would be being forced down too. It would be driven counterclockwise. So they'd be going in opposite directions. The only way you can get away from that is if you put in an idler gear. Down here is what we call an idler gear. And let's say this one was the drive gear and it was spinning this way. Well, then the idler would be caused to spin this way, which would also then be pushing and causing this gear over here to go the same direction. So once again, if this was our drive gear, this right here would be an idler gear, and this would here just be our other gear. I'm not exactly sure what kind of gear they cause that, but the idler gear is what allows them to both travel in the same direction. Gears, the RPMs of gears. The larger gear is always the slower one. So let's go back to here. This bigger one right here is going to be traveling much slower than this small one. You can just think about that as being, if a parent was walking their 3-year-old, the 3-year-old has to walk a lot faster to keep up with the parent because their legs are a lot shorter. There's not nearly as much movement here. The smaller one then is always going to travel much faster. And that also has to do with circumference. The larger one has a much larger circumference, so it doesn't have to travel as fast to go as far every turn. Gears lock together in the same shaft. They turn in the same direction. So down here now, we've got some gears that are locked together on the same shaft. This shaft running through the blue one and the yellow one. If the yellow one is turning in that direction, then the blue one has to as well turn in the same direction. And they're also going to have the same RPM. Put a little mark there. Every time this goes around once, this is going to have gone around once, because these two spots are going to stay coincident of each other. Gear ratios. We've got some terms here we've got to learn. And these terms here, N is the number of teeth, D is diameter, W is angular velocity. That's going to be probably the harder one for you to remember, and T is the torque. Down here, they've given us two different gears, and they've given us all this information. And here they're talking about the gear ratios. These are important equations to learn if you're going to learn the gear ratios, and you're going to have to be able to do this quite a bit. I would make sure I get these down because you'll use them quite a bit working with gears. And can be done. You can think of these sometimes as calculating mechanical advantage as well, but we'll get into that here in a second. What I want you to realize here with these, and it shows it down here at the bottom, is that we've got this larger gear and this smaller gear, and the gear ratio is 2 to 1. And what that really means is this bottom one's going to have to go around twice as many times for every one time the larger one goes, and that's what we said, is that the smaller one's going to travel much faster, and the bigger one's going to travel much smaller. And it doesn't matter which ratio you use, you get same answers, 2 to 1, 2 to 1. If you reduce these, you're still going to get 2 to 1 every time. The units still cancel out, and you still get that same gear ratio of 2 to 1. Okay. Rotational. I said we get into mechanical advantage. Rotational equivalent to mechanical advantage. It's not the same as mechanical advantage in all circumstances, but if we think about it in terms of force, input and output force at the axle, if we have a very small idler gear, what happens here then is the amount of force that's being put into this small axle because of this, into this axle because of the small gear. When it comes over here, you're going to get twice as much force at the axle. And this is why, like on a bicycle, if you want to go uphill, you're going to change the front sprocket to a really small gear, and you'll change the back sprocket to the biggest gear possible. And that's what's going to allow you, because you're going to put a small amount of force into it and get a much larger amount of force out of it at the axle. All right, it's when this mechanical advantage works when we're talking about getting force at the axle. Notice it's here at the axle. It's going to cause the axle to turn here, not out here. It doesn't work when we talk about force out here. All right, and that's because the forces here are going to be opposite and equal. It only works when we talk about getting more mechanical advantage at the axle. I don't know if that's how you spell axle. If I misspelled it, it'll be easier for you to remember. Here, they go through a lot of stuff to say that it doesn't work anywhere except for the axle. Here, they're telling you again that it only works at the axle. And the reason is, if you go here at the gears where the teeth are, for those of you who have taken the physics class, we know that for every force there's an equal and opposite force. So if the red one were to be pushing down with a certain, I would draw these going the opposite directions, but if the red one, we'll say here, if the red one was pushing up over here with a certain amount of force, then the blue one has to be pushing down with an equal and opposite force, otherwise it would pretty much blow up. So the forces, again, are only there at the axle. Okay, gear ratios. What is the gear ratio between A and B? Well, we can, if nothing else, we can count the teeth. And by counting the teeth, we get a gear ratio of, this is our drive gear right here. And so we have 20 teeth here, and we have 12 teeth here on out. The drive gear is what they're going to be calling the in. We get 0.6 over 1. What is the gear ratio between B and C? Well, B and C right here. B in this case becomes the drive gear, and it becomes, because it's being driven by A, which means B then is driving C, and it gets 5 over 12, or 0.42 over 1. What is the gear ratio between C and D? Well, C, becomes the drive gear, so it's 5, and 20 is the output, and it becomes 4 to 1. So here is how we do gear ratios in this case, even with this compound set of gears. What is the total gear train ratio? Well, what we're going to find out here then is that the only two that really count are the first one and the last one. The other ones cancel themselves out. And that's what they're showing you here with the between A and B, and then B and C, 0.6 and 0.42. If we take these and multiply all of these gear ratios up, we get 1 to 1. But if we simply, and the reason that is look at the first gear one. First gear, we got 20 teeth. Look at the last gear, we got 20 teeth. So you could have simply said, what is my input versus the absolute last output, and it gives you 20/20 or 1:1. If you wanted something different, let's just imagine for argument that D wasn't here. If I wanted to do the exact same thing and find out what kind of mechanical advantage am I getting, or what kind of gear ratio am I getting between A and C, again, my input would be 20, my output would be 5, and I'd have a gear ratio here of 4:1. And that's what they're kind of doing here in the last one. They're just making it a little bit different. Compound gear train. The two middle gears share a common axle, so they rotate at the same speed. This allows the final gear to rotate slower and produce more torque than if it were connected only to the driver gear. So what they're doing here, again, we know that we have a driver gear. Clear over here is our drive gear, and it's moving really fast in comparison to the yellow one, because the yellow one's bigger. Well, because the yellow one's moving slower, the green one's moving slower. And what that's doing now is, because it's able to move slower, it's able to give us produce more torque. And this is useful in making a compound gear. If I wanted to get a lot more power here, or a lot more torque, you would want to use a compound gear train. And what we're talking about here is this axle is the same axle that the green gear and the yellow gear are on. And you'll get to make one of those today or tomorrow. Compound gear ratios. Well, what we do is, again, what is the gear ratio between gear A and B? Well, A is my drive gear. B is the one being driven. So 10 in, 4 out gives me a gear ratio of 4:1. On the next one, 20 now, because it's connected to B, becomes my drive gear. So 20 is the in, 50 is the out, we get 2.5:1. So just like a pulley system where we said we multiply all the pulleys together, we do the same thing here with the gear ratios, and we get a gear ratio of 10:1 with this. And this would work, mechanical advantage would work in one situation, as long as we were talking about force at the axle, which means for every 1 pound of force that this drive axle was producing, you would get 10 pounds of force on this axle over here. Or if this one was moving at a certain speed, this one over here is going to be moving 10 times slower. So at any rate, I hope this was beneficial, and I'll see you on the flip side.